So you do the support still. Nice, nice. Who else? And you're working in Bolt. Nice. We have some more people from Bolt. Where are they? Bolt people. Nice. Let's do the round of applause to Bolt people. Cool. What are the projects you're working on? Micromobility, the food delivery, or? Nice. Nice. That's the right place. Actually, fun fact: the first ever engineering meetup that we had in Tartu was together with Bolt, and we had Vyacheslav there, the Vyacheslav Nechiparenko, the guy who was like sixth engineer at Bolt, and he was behind micromobility and scooters, which is the same actually. Are we live? Yes. Nice. Thank you. Welcome to Pipedrive Tartu. Pipedrive, right? So it has been founded many years ago, already 15 if I think about it. In 2010 by 5 Estonians, and some of them had engineering background, but some of them had this very hands-on sales background. If you know, like I didn't know, I'm a foreigner in Estonia. I got to learn it only when I came here. That in Estonia there's this thing, you can go to States, to US, and you can sell these books door to door. The Southwest Advantage, I think this is how the company knows. You know guys about it, right? So they did exactly that. This is where they learned that, well, sales are complicated. And there would be cool if there would be a tool that simplifies sales, not for the managers, but for the salespeople. And that's what they did. And fast forward to now, we are available on desktop and also as a mobile application. We have over 108K companies, customers, so like we are B2B, which means that people who use us are companies, so it's like 100K companies, but there might be like one or actually 300 users behind one single company. 850 plus employees, 50 plus nationalities, me being the bright example, and 10 offices in 8 countries. And we are also proudly the 5th Estonian unicorn out of currently 7, depends on how you count, but yeah. And we are really pleased to co-organize this event today with a community called PyData Tallinn, unironically in Tartu, and we'll have Andreas to talk more about it.
Thank you. My name is Andreas Bieger. I'm one of the 2 co-organizers of PyData Tallinn. The other co-organizer is Isaac Chung, over there, he's waving. PyData is a community for data professionals, so data scientists, people working with AI, but also the sort of more conventional data professions, data engineering, data analysts, basically anybody whose day-to-day work involves turning data into something useful. We as a community, what this basically means for people like you is that we organize quarterly meetups, usually as the name implies in Tallinn. In fact, our next meetup will be March 5th at Bolt. And I'll be sure to call out any Pipedrive people in the room then, so you can have your payback and revenge. But so we are here today. We organized this event together with Pipedrive. This is our 2nd event together with Pipedrive. We had one last September in Tallinn, and hopefully we will have one again, anniversary edition in the fall in Tallinn again. That's all for us. So I hope you find this interesting, and if you do find it interesting, then check out our future events. And if you need a reason to come up to Tallinn, then we're happy to provide it for you, and hope to see you at a future event. And with that, I'll introduce our next speaker, Pavlo.
Yep. Go ahead. I don't need this.
Oh, okay.
Yeah,
good. Yeah,
thank you. Hello, everyone. Nice to see you here. So. I'm Pavlo, and I've joined Pipedrive a little bit over 4 months ago. I'm a junior machine learning engineer here, and I'll tell you a bit about what I have done so far and what we are working on. And the topic is automated machine learning pipelines. The agenda is the following. I'll talk about what are machine learning pipelines in general and which tools do we use to set them up. Then I'll describe high-level overview of machine learning workflow and how models are developed. And lastly, I will talk about the overview of this automation framework that we have in Pipedrive. But I'll begin with the problem statement. Why is automating machine learning pipelines important? Why it's necessary? The deployment process is quite complicated, and as you will see in the future slides, there are many tools that are needed and many components there. And there are many repeatable components in machine learning pipelines. And therefore, we want to reduce the amount of repeatable actions we do. And the benefits are faster deployment process, less mistakes during deployment, and simpler code base. So, what are machine learning pipelines, and which tools do we use to build them up? In general, there are two kinds of machine learning pipelines. One is dedicated for training, and the other for inference. They have some similar components, for example, pre-processing or post-processing, but some things are different. And in red boxes here are outlined the most important things for the production ML pipelines. And pre-processing, it involves preparing features and building machine learning features that will be used for training the model. Hyperparameter tuning, first important to explain what hyperparameter is. It's a kind of parameter that has to be set up before the training starts, and it cannot be learned through the training process of a machine learning model. So a machine learning engineer has to decide which value to set such that the model will perform the best in the end. And then the training process is iterative. You, in every iteration, take a batch of data with labels, and the model makes predictions, and they are compared against the actual values. The difference or the error between the actual values and the predictions are calculated using so-called loss function. And in the process of training with each iteration, the goal is to minimize the loss function such that the weights in the end and the model performs with minimal value of the error. And also in the training process, we need not only the training set, but the validation set. And that's a separate set of data which we use to evaluate the model using metrics. For example, if we solve a regression task, it's a mean absolute error, or if we serve a classification task, it can be accuracy. And so we use the validation set in order to evaluate how does the model generalize, and how well does it work for the data that it hasn't seen before. And this is also the assessment part, which is on this upper pipeline. The model creation is basically saving the weights that were trained or obtained as a result of training and saving somewhere in the storage. The inference pipeline also has pre-processing, has assessment and post-processing, but inference differs in a way that the model that was trained is applied to the new data, and then the predictions are served to customers. So this is already deployed such that the clients, the customers, actually see the results of the model. And for post-processing, also in production, it can be useful to add feature importance analysis tools. For example, there is an algorithm called SHAP values, and it helps engineers understand which features are more important for the model. So this is, in general, what is a machine learning pipeline. And here are the tools that are important in Pipedrive for building these pipelines. First one is Amazon Simple Storage Service, for short S3. This is kind of a Google Drive, but with much more functionality for storing your files. PySpark we use for building features and feature store with the data that we have. XGBoost is one of the most used machine learning models in Pipedrive, and I'll have a bit more details in future slides about this algorithm. Airflow is a tool for orchestrating and scheduling machine learning workflows. Amazon SageMaker is used for deploying machine learning models so that you have them run in production. And Docker is used in cases when the SageMaker images, basically the environment that it provides, is not sufficient for our needs. And in that cases, we create our own images using Docker for our specific environment. And there are many more tools, but these are the most important for us so far. And I'll describe those tools a bit more detail one by one. Airflow, again, it's an orchestration tool for building workflows, and one of its benefits is flexibility. It enables you to build complex workflows across different systems. So you can integrate in one workflow many different tools. It's also scalable, so it handles large-scale parallel task execution, and it has nice dependency management, which means that you can specify inter-task dependencies. And as you could see from the previous slide, there are like steps that have to be executed in specific order, like pre-processing, training, and so forth. So this is an important feature. It's also extendable, so you can add some custom logic for yourself. And it allows scheduling. So it offers robust time-based and event-triggered scheduling. So you don't have to manually run those pipelines. You provide a schedule, and it will run for you. And this is the user interface of Airflow with some of the models that we have. And important concept here is a directed acyclic graph. And this means that basically the tasks are in a particular order, so they cannot loop back. Basically, you cannot come back to pre-processing if you are in training stage. And in this user interface, you can see when the models were run, what is the frequency with which they are running, like weekly, daily, monthly, if the run was successful or not, and so on. And we can take a look at a specific directed acyclic graph, which represents an ML pipeline. And it's hard to see, but there are pre-processing stage there. There is training, transform, which is respective to the inference. And basically, for every day, there is a column, and it shows you that it was scheduled and run on that day. And the green boxes just show you that it was successfully executed. Here you can see also the logs, the code for creating these DAGs. So it's a useful interface for machine learning engineers. And this is a closer view on those tasks. As you can see, there are 4 at the top are like feature store tasks that basically extract features from the database. Then there is hash generation, which I'll not get into detail, but it's just a trick for making this particular run unique, like providing it a unique ID. And then there are these traditional machine learning steps that we saw before. And this is the DAG view, actually, like the graph. The next tool is extreme gradient boosting. It's a useful tool for both classification and regression tasks. It's an assembly learning method, which means that it is built up from the simple so-called weak learners, which are good at solving some very simple task, but bad at solving some more complicated tasks. But when they are put together in an ensemble, they actually perform really well. And the usual algorithm for the weak learner is the decision tree. The XGBoost is also good at handling missing values, so you basically don't have to impute missing values yourself. It is highly performant. It wins many machine learning competitions, and specifically on tabular and supervised learning tasks. It is interpretable, so you can basically understand why it makes particular predictions, and it's scalable, so you can apply it in large companies like Pipedrive. And now for Amazon SageMaker. This is quite a huge tool, and there are many components to it. It's mainly used for deploying machine learning models, and it has a nice integration with Amazon S3 storage. And also it has SageMaker notebooks, which are, it's a coding environment for experimentation, where you can see the output of your code right away. So maybe you're familiar with Jupyter notebooks. It's similar, but the benefit is that you have the connection with Amazon web-based services, so the Amazon cloud resources there, and that's much more than just your local computer. And it has an API, so you can call specific functions from Amazon to perform tasks, and that's what we do. We call functions such as create processing for pre-processing tasks or post-processing. We call training job for training, model for saving the model artifact, those weights that are a result of training. We use the transform job, which is for inference, both when making predictions on the test set during training and when making inference that is served for customers. And there are many other functions, but we use only these so far for ML pipelines. And this slide kind of puts it all together, the general machine learning pipeline view with the tools. So as you can see, PySpark S3 is used for feature store, SageMaker is related to pre-processing training, model creation, inference, post-processing, and the results of assessment like metrics are dumped into storage on S3 as well. And XGBoost is used for training and inference. Now, let's talk about high-level overview of ML workflow, how the work is organized. We have a data science team that experiments, and at some point they come to stakeholders and they get business requirements. They understand what the data is available, what's the business problem that needs to be solved, and then once they have a clear understanding, they start experimenting, which they do usually in SageMaker notebooks, and they perform feature engineering there, data pre-processing, they tune hyperparameters, and implement post-processing. And this process is actually iterative, so it can loop again and again and again based on the feedback from stakeholders, but at some point, the model is good enough, and then they go they go to the machine learning engineering team for deployment. And machine learning engineers also need to talk to stakeholders, but then they also have to understand what data scientists came up with. And once they have that understanding, they need to convert that experimental code from notebooks to production code into processing scripts, post-processing scripts, and the actual machine learning pipelines using those tools I described before. And also an important concept that that we work on right now in Pipedrive is a machine learning self-service platform. And the idea is that data scientists, analysts, and data engineers should have tools and to build, train, and deploy machine learning models by themselves, so that they don't rely on a central data science or data engineering team. And it is related also to a concept called data self-service, which basically means that also domain teams, for example, marketing or sales team or HR team who have their own data, that they have isolated environment to work with that data. They have the tools to query that data and to develop solutions working with that data, and agree on a set of rules and responsibilities that domain and central teams will follow. So it kind of provides decentralization of domain teams from one central data team. And ML service is built on 4 pillars. I've told you about this self-service data platform, which is one pillar. The other is machine learning development and experimental environment. And that means that also developers have tools to build and deploy machine learning models. ML runtime environment means that developers should have tools to execute those machine learning pipelines, so compute. And data and ML governance is about following policies and guidelines from the company so that regulations are met. And this is important for automation as well, because with automation, we want to also make this easier for every team, so that not every team doesn't have to set things up from scratch every time. So now we come to automation pipelines, and what do we have currently in Pipedrive? It's basically we have one file that defines things that are common between machine learning pipelines, like resources, compute resources, or stages of pipeline that are the same. And we have another file that has very specific definitions. For example, a path to a particular processing script, or a list of hyperparameters for that particular model. And then we basically merge those two, and we generate from those two files the full configuration that would take a lot more time to write from scratch. So that way we save time. And that full configuration is then used to generate code for Airflow. And in Airflow, there is Python-like code as well that is used to define those directed acyclic graphs. So we have a repository that converts this configuration into Airflow code, and then those pipelines can be executed and scheduled in Airflow. So a bit pictures of roughly how it looks like. So on the left, this is kind of this parent file with parts, for example, like unique timestamp, just one argument that is used for every machine learning models, like as an input. Also this processing resources, it's the default, so we don't want to specify this every time, which resource do we use. And on the right, we have this file with specific configuration. And I highlighted here, for example, path to processing scripts that are specific for this particular machine learning model. And yeah, it's then converted into this Airflow code, which is just an extract of it. You can also find it in this user interface on for Airflow. And as you can see, those processing scripts, they were basically put into right places. Here, like unit timestamp and the path to the processing script local dir. And here was specified the resource that was used for this post-processing stage. So, and this is one more just picture from the Airflow UI of this Airflow code for DAGs. So it basically allows specifying these machine learning pipelines in much less code. And yeah, we are working on improving this and making it more easier so that we can provide this machine learning self-service platform so that as more data scientists and ML engineers come to our company, then they can start adding machine learning models and deploying them easily and yeah, and quickly. So that's it from my side. Thank you very much for your attention. Yeah.
Thank you, Pavlo. I will Thank you, thank you. We'll do one trick. We'll do this, and please, welcome. So we have a Slido for some reason, because while it's there, you can just ask questions live. But since we're in Estonia, we know that sometimes not being able to speak but being able to write is a valuable offering. That's why there's Slido. But if anyone has any questions he or she wants to ask live, please go ahead. Yeah, I guess I'll just do this way. That I'll. Do we have? Anyways, yeah. Just go ahead.
Have you tried using other orchestrator tools, and how long are you using Airflow?
Well, I think Airflow has been used for already quite some years, but I know that one of my team members from data engineering team recently experimented over the weekend with some other orchestration tool. I think it was called Dagster or something like that. He said that it had some more nice features, but we don't use it yet.
And so you decide to stay on the Airflow and do not change the.
So you decide to stay on Airflow and do not change the environment and processes and all that.
Yeah, so far Airflow is good enough. Yeah.
Thank you.
Thank you so much. We don't yet have any Slido questions, so maybe there's something that you want to ask live. Eva wants to ask a question.
What are some Pipedrive features that use ML models?
For example, engagement score. So we have a model that basically provides to our CRM users understanding of how the customers are engaged with their proposition or their company or salesperson. So it is also XGBoost based model, and it provides a score that is like a prediction that is then converted into a number from 1 to 100, and it's then tiered actually into 3 levels, like low engagement, medium engagement, and high engagement. And so far, it was developed not that long ago, and more improvements will come with this feature. Yep. And this is a customer-facing machine learning model. There are also models that are internal. For example, there is a churn prediction model. So basically, it predicts how likely a customer is likely to churn or stop using our services, or rather the services of the user of our CRM.
Sounds like a really useful tool. Thank you.
Thank you.
Thank you.
If we don't have, we do. Yeah, we will get back to Slido once we run out of questions. That's the drill.
So we saw one example of automating the training pipeline. I was curious about the deployment. Is it somehow also automated, or is there some human factor to it to check the train model first?
There is human factor still. Yeah.
Okay, thank you.
In Slido, Gert asks, what kind of data is fed to the ML models to train them?
We have one more question. Hey, one more question here.
Ah, sorry. Here, let's go with 11.
Yeah, I wanted to ask about that data self-service thing. What is kind of the main purpose? As I understand, it's like the thing to be able to skip, going to some data engineer in another team to create data pipe, ETL pipeline, and put some data in the table, and then only you can take the data and do train some model with it. Or I don't get the purpose by now of this data self-service thing. Maybe you can expand a bit more.
Yeah. So the idea is that domain teams, again, for example, marketing or salespeople, and they are analysts. They don't depend on one centralized data engineering team to provide them with the tools or to provide them with the data. they should be within this framework able to query their data by themselves or build models from the data. And the central team will only provide them with tools for working with that data.
Okay, but if you have like, okay, maybe I'm going a bit into detail, I'm sorry. But well, yeah, okay, I get it. Yes, I won't go too much further.
And you still can go into details when we finish the talks and when we have snacks afterwards and, mingle and talking to each other. So definitely approach Pavlo and, continue.
Hello. I'm curious, do you experiment with large language models in product or in your internal services?
Yes. For product, there are quite ambitious goals to use large language models for building agentic workflows, but for internal use, we don't use LLMs so far. And there is a separate team dedicated for this product. We call it Product AI, and moving towards this goal of agentic workflows and building agents. They have their own data science and ML engineering team. I'm working more on internal machine learning.
Okay, cool.
But it's also not like we plan to build large language models ourselves. We use OpenAI APIs.
But actually, there's one internal use case where we categorize the voice of customer initiative, when we categorize customer feedback using embeddings and semantic search to kind of bucket them into certain groups and address them accordingly. So that, I guess, counts as the LLM use, but it's exactly internal one.
How do you deal with PI data?
Personally identifiable information
Yes.
carefully.
Is it like if you use a commercial API, do they offer like a I don't know, B2B integration where like they take care of the data, or you simply like filter it before the external API? If you don't know, that's fine.
Yeah, I don't really know.
Okay.
Yeah, that's cool.
All right. Then finally, Gert gets his question answered. What kind of data is fed, I guess, to the ML models to train them?
Oh, there are many. So it's data from our CRM. It can be, the features that can be used is for example, when was the last email sent, when was the last video call made, or like snippets of the information or summaries of the information of the deal. So there is a concept called deal in CRM that represents the kind of communication or interaction of the salesperson with the customer, and there are a bunch of attributes related to deal, like its value, or like what was the communication within that deal, or some like monetary value. And so those things can be used as features, and it's related to deals and the sales pipeline, so those things can be used.
Thank you. Moving to the next one, Isaac is interested in what is the most challenging part of the pipeline to maintain?
Yeah, currently it's this the first part that I showed with these files with configurations, and that's the focus of the work right now that I do, is how to make it simpler. So there is also work done on we have like a repository that does this rendering of configuration files into the code that is then used for building Airflow DAGs, and there is a lot of work done there to improve this and make it more efficient, how we render code for Airflow DAGs. But for me personally, right now, this work with the configuration files is most complicated, and I'm trying to make it easier and simpler right now.
Jonas is interested in, yeah, that's quite a net. Any data quality checks, Pavlo? What would you say?
Yeah, I personally don't work with that closely with data right now, at least in this 4 months.
I assume the Pavlo is maybe the wrong person to answer, so because we have data engineering team who's like behind the data pipelines, and I guess it's done way before you get the stream. Yeah, but good question nevertheless. We'll make sure to have the data engineering person next time. But Ivan asks any other models, algorithms, otherwise XGBoost.
Yeah, so there is also one model that is a recommendation algorithm, and we use for that a model called LightFM. So it's also, it provides kind of ranking of apps. So we have like apps within Pipedrive CRM, that kind of plugins, and this model provides ranking of those apps. Yeah, and yeah, also OpenAI calls, OpenAI API calls, as I said.
Thank you. Vyacheslav asks, so it's apparently a question more about machine learning engineering. So are we developing models using OP and Solid, or sometimes it's spaghetti? Wow, time for confessions.
Yeah, it's a lot of OOP code, but it's still Python, so you kind of, some would argue that Python is, but yeah, I would say there's a lot of OOP there. Well, and I have to be honest, sometimes spaghetti as well.
But mostly you said like when you just like on the stage just like preparing something, some draft and all the stuff, like is it could be spaghetti code and or it's like from the beginning when you start writing ML, it's like should be all very solid. Like
Yeah, it's like it is usually has to be in OOP, but it depends also. Like if it's a pre-processing or post-processing script, for example, then no, it's usually functional programming. So you just define functions there and so on. But like for example, we have like a code base for converting those configurations into this Airflow code, basically. And there in that repository, there's lots of OOP, and it's basically all based on that principle.
Last but not the least question from Isaac. Why is the config file part is the most challenging to maintain?
Because it's a lot of debugging right now. So to make it work, I have to debug things, run all the pipelines like from scratch. And when I change some principles behind these configurations, I have to rerun the whole machine learning pipelines to test these changes, and it takes a lot of time. Yep.
Okay, now the really the last question, for real this time, for real, is are there any general and specific configs that are merged in the full config as a part of Airflow deck task?
Well, for example, the processing resources. So you can, in this, it's for lack of a better definitions, in this specific config, you define like which AWS resource you want to use, like which machine, and yes, that will be then overridden into the general config, and that way you kind of overwrite the defaults. And it's similar with other things. So you, by specifying the specific parameters in the, sorry for repeating myself, specific configs, but you overwrite the default things. So that's how it works.
Thank you, Pavlo.
Thank you
so much. And if that sounded fun, and you want to do it maybe yourself, then actually, coincidentally, we have data science and machine learning intern opening in Tallinn. Applications are open until end of March. Please apply and do some cool stuff like this. But for now, we have a little break, and you can, go to the places that we all know. You can take a drink to refresh yourself. And then next one, we have Javier talking about AI agents. Wow. So yeah, a little pause for now. Thank you. All right, but I think it's time for the second, which is also the final talk. And it's my pleasure to introduce Javier. And a few words about Javier. We actually, so first of all, Javier is Chief of Protocol Development at the company called Easy Feedback. But there's one fact that I learned about him a couple of days ago. So apparently, Javier has an interesting hobby. He teaches at school besides his normal work, which takes a lot of time. And how do I know that? Because I have the similar hobby. So high five with that. Cool. But yeah, the stage is yours. Please.
Thank you. So, hello everybody. Just before we start, the title might be a little misleading. When I wrote it, I didn't think much about it. So I'm not really gonna talk about agents as agentic now systems or that kind of agents in AI. The idea is more using just, we could say AI chatbots or AI tools or whatever, just clarifying. And as my background, as Mihailo well said, I work as a Chief of Protocol Development in Easy Feedback, at Easy Feedback, which is just a fancy name for Web3 developer. I could say that protocol development in the sense that I work in the architecture of the system and writing, like I haven't wrote code for that in some months. I've been mostly writing documentation, which is boring but necessary. And also as a hobby, but not that much of a hobby, I teach in high school in the old town in Tallinn. That's super fun. One of my former students is here. I hope there is no trauma in there. And I teach programming and electronics, and we build electric cars and this kind of stuff. So let's go back to the title. Analyzing and predicting system prototypes with AI, let's say, that's the goal. And the idea came from the need to design a prototype of the model we are using for our protocol and understanding how it would behave when users starts like growing and what are the different inputs to the system, what are the different outputs, how the different factors are related. But we wanted to test that before building the system because you don't want to build something that doesn't work. So that's one idea why we started trying this. Also finding a balance point on what are the right parameters for the system you are designing, as well as studying the different possible scenarios. So when you design a system, you have different parameters, you have different stakeholders, different outputs. But usually you have like too many of those and you have to choose which ones. But how do you choose which ones? The only way is to do a model of the system to kind of build a prototype. So the idea is that today I'm going to show some tools on how to quickly do that before actually going into even test development and then production. Also like fine-tuning, like finding what happens if I change a bit of this parameter. The first example I will put is taken from engineering. I actually have an engineering background, not an IT. My IT is my master's. So usually when you have systems oscillating, a very small change can mean that the system crashes. That happens also in computer science sometimes. So it's good to find what are the right parameters. And I wanted to find something that was easy to share and very quick to deploy. So I don't need to build some pipeline that later no one will maintain. The thing is this is just like one use and then you can just throw it to the trash bin and that's enough because you just wanted to test. So that said, I'm going to talk about the Streamlit. I'm not sponsored anything. I don't know who is behind that. I just have used all the free tools. I haven't paid anything. They haven't paid me anything. And I found it because of a coworker in Taltech. I was helping in a robotics course, and they were using this for educational purposes, and it's super useful. It's a framework that allows you to build very quickly dashboards that are interactive, and interactive in the sense that you can very quickly build parameter like sliders, buttons, selectors, drop-downs, whatever, as well as file inputs and other things. And it requires here says minimal front-end experience. I would say none. You don't need to know. I haven't touched any CSS, for instance, like absolutely nothing. And And yeah, the use cases are like countless. You can even build ticketing systems for IT systems. That's one example. But this widely used in academia for exploring data sets, for instance, and also like exploring how like pre-training data is and how post-training data has changed. That said, I will just show some examples. Since I cannot show what I did with my company, I spent most of the time of preparing the presentation, breaking my head on what are the examples that can be appealing to the audience. And I didn't know exactly what the audience was going to be. I guessed that some data scientists, interesting people. So that's, yeah. There are 3 examples. I hope some of them are interesting to you and you find some useful ideas behind this. So the first one is a PID controller. If someone wants to check it, it's on that address. One good thing of Streamlit is that it's very easy to deploy things that you can put in a public URL and share it very quickly. So this is an example. I did this one. I didn't take it from anyone. And since I was expecting at the beginning that I could use my computer at the same time, but didn't talk much about it. I just had to make a GIF of it, which is not working. So I just hope that the GIF is not there. It's okay. I guess we'll just keep going. So if you have opened the PID controller, you can check the dashboard. I don't know actually how it looks in the phone. I never tried that. So this is the place where you haven't tested things, so I hope it looks good and you can try things. But the idea of a PID controller is that you can change mainly 3 parameters: proportional, integral, and derivative, integrative and derivative. And that's used when you have like oscillating systems or well, any kind of system that has an impulse or a step, and how it reacts and how you can control the system so that you can achieve a set goal. So if you check there, you can set a point that you want to achieve, either it's 5, could be whatever. It could be voltage, it could be water level. There are also some examples in the website and somehow explained. If someone has an engineering background, it's easier to understand. If not, I think it's still some basic physics helps to understand. The idea is that by playing with the parameters, if you check, you try a bit of the proportional gain, for instance, you can see how the oscillating curve goes closer to the set point. If you add a lot to the derivative component, which you have there, it helps actually to dump all the oscillations and get to some more stable point. And if you start getting closer to the set point, you still need to add a bit of the integrative gain, so you can actually go to the set point. And that's how engineers find what are the right parameters for controllers, either of servo motors, for instance, or like the example that is in the website of a chemical reactor, or like water levels in a deposit, in a tank of water, like dams. They use this kind of systems, well, a bit more complex, but the main idea behind it is this one. And it took me just a prompt to create that, and that was the prompt. Well, I wrote like 3 more after this, just to like fine tune it a bit. But just with this, I got the code, put it in a GitHub repo, upload it, and that's it. Okay. So guess I'm now a prompt engineer, not a developer anymore. And I used to be like, yeah, prompt engineer, that's a fake title. Well, I still think it's a fake title, but it's good to be a programmer and also a prompt engineer. It's very useful when you have to do quick things. I guess I lost my point, but we'll go back. So this prompt that you see here, I actually extrapolated and made it into this prompt. So if you follow AI gurus on LinkedIn, you will find that they are all the time sharing prompts. Well, I guess I can say I'm an AI guru now, that I'm sharing some prompts. I'm not, just for the record, I'm not an AI machine learning engineer or whatever. I have a basic understanding of it. But I have found that this is very useful for quick prototyping. And why Bokeh is another graphic library, open source library in Python for cool graphics, is, in my opinion, a bit better than Matplotlib because it has by default already some cool visualizations. So if you go in the computer to the website I share, you can hover over the different points and it gives you all the data about it. So for people that like numbers and data, and I guess that's the kind of audience, it's pretty cool. So yeah, that's why I usually specify to use Bokeh and not something else. So yeah, the point of this is just go write some prompts and just do quickly things with it as much as you can in your daily job. So now I'm gonna explain a bit of how is the deployment process of a Streamlit. So this is kind of the dashboard where I have different things. And you just basically go up there, click create app, and you have 3 options. I only use one, and it's GitHub. So to the GitHub repo, I usually have 2 things. Well, usually more, but with 2 things is enough. A Python script and a requirements.txt file that says which libraries you are going to use. That's all you need for deploying an application in Streamlit. No config file, nothing to maintain. We'll see, that's a bit more complicated than that, but yeah, the requirement.txt file, the library. I was expecting to have my computer show, so that's why I didn't add a picture of it, but this is pretty much 4 lines. Setup tools library, Streamlit, NumPy, Bokeh, and Pandas. I guess in the future it will be Polars. But yeah, you just connect it to your repo. So this was the example. I did the repository. Actually, one cool thing also of the Streamlit application is that it has a button on the top right corner that links to the GitHub repo. So you can actually go directly to the code and see everything behind the curtains and how it is written. So if you want to later check it on, it's everything there. Disclaimer, most of the code is AI generated. I have written maybe 3 or 4 lines. The rest is directly from the prompt. Well, I'm lying. I haven't even written 3 or 4 lines. I just changed 2 lines and didn't even wrote them for this case. So it's very easy. Just check the repository, which branch, which is the script. That's the only script in the repository. And then you even can choose the URL, which is cool that they offer this for free. I still don't know which is the maximum amount of repos that you can have. I haven't tested. I haven't looked at the pricing, but I haven't hit the limit yet, so it's fine. Then one important thing is that you have some advanced settings, and this is important because when you use chatbots, you know that they are usually 1 year behind in the internet information. So this means that the libraries you're gonna want to use are from 1 year ago. That means that one thing that I found out by trying is that you want to use Python 3.11, not 12. And that's something you want to set up from here, because there are several errors that I will show later that happen when you do this. If you know that, then I literally can tell you that it's just one prompt to build these things. If you don't, then you can just go asking for fixing the errors. You can also have, here is just the template behind, but if you have some secret API keys or whatever, you can also add them. So you can really build a full application on this with authentication and whatever. I haven't done it because I haven't needed to, but you can. And the only other requirement that is not written here, but if you look at the documentation or the README file in the GitHub repo, is that you need a requirements.txt file that, for those who don't know, is a way of describing what are the libraries that your Python project is going to use. It's a very simple one. It's the most basic one you can have, but useful for many things. So here is another one that I built, and it's for analyzing server logs. In the GitHub repo, there is also a Python script to generate fake server logs. but you can actually use it with real logs. The only important thing is, well, we'll run to the only important thing to take into account, but yeah, you can use this, and I also had like another GIF, GIF, however you pronounce that, showing how it is, but I guess you can just try. Well, actually, you cannot try it for one simple reason. I'm sorry. I wanted to do it in the computer, and it's because this one has a functionality that you add the log file, and you don't have the log file. But the thing is that you can easily add any log file, and it will do the analyze for you. So that's the only problem. So sorry that the example is not a very good one, but if you later check the repo, you can also play a bit with it. You can generate a fake log file and analyze what are the failed call API calls, what are the times where there are more calls, yeah, the different kinds, if it's post, I mean get, delete, put, whatever. And yeah, this was also one prompt. But it's not everything ideal. If you have been trying to build things with ChatGPT or whatever, you know that if you do simple things, it's okay. If you try to do something a bit more complicated, then you spend most of the time just debugging. I still think it's useful to try it, because usually I wouldn't say these are the real times. You usually spend less time than what you would spend if you don't use AI. But you fall into some errors, and you can keep asking the AI to fix these errors. But as I said, you have information from 1 year ago, most usually. So often you are the one that has to be intelligent and developer and find the solution to the error. Like one that I found is that I wanted to use Python 3.11 instead of 3.12, but in my computer I usually have 3.12, but I wanted to use at the same time different versions. So a very easy trick and quick to fix in Windows is that you just change the name of the exe file, and as long as it's in the keskkonnamuutujat, the environment variables in the path, then it's okay. You're a charm. Instead of writing Python and whatever script name, you just write Python 3.1, which is what I rename. You actually can write whatever BS you want. I mean, you can write like BS and execute a Python file, which is funny. I didn't know before. But the more than funny, is actually useful to just rename your Python versions if you want to use them at the same time. Or just have a Docker file or or Anaconda or something that is actually cool. But I didn't want to spend time or setting that up, and I usually don't use Conda. So yeah, this is a quick hack. Now going to prompt engineering. I don't know if you have heard of the term tiny crabs ride enormous iguanas, but it's a very useful term for prompt engineering. So if you want to do a good prompt that is very useful, just remember of this picture. And take into account that you just want to know that in the first prompt, you just need to write the task, the context, and the references. And the references is not like writing the bibliography in your thesis, but more of saying that the example that I put before of the server logs, the reference means that I'm going to tell that the server log format is this one. That's the reference. So if you give it the example, then it's going to work a lot better. And evaluate and iterate go after the first prompt. So you check it, you have to read, you need some critical thinking, or even you can use another chat and ask to analyze it and evaluate it, which actually works, and then iterate over it. So yeah, tiny crabs ride enormous iguanas. If you want a cooler version, this is more epic. I was just bored yesterday and asked ChatGPT to generate this one, and I said, well, a more epic one, please. And this was the more epic one. Yeah, I guess. And I wanted another one, but then I ran out of tokens. So yeah, we stopped here. Another example, and this is the last one, I promise I will not make you suffer anymore, is I thought, what if I want to open a bar? I have never opened a bar, but it's one of my dreams. And before doing that, I need to make sure that it's gonna be profitable, that I'm not just gonna get broke, which is very usual with bars. Restaurants and bars, from what I understand, are not as profitable as we usually think. But I don't talk from experience, so just from what I've heard. Anyway, I wanted to just create a quick dashboard on Streamlit of how could I analyze if my business is going to be successful and what are the things that I need to take on account. But I have never run a bar before, so I started with the tiny crabs ride enormously one as idea by first writing this. First I state what is the general goal, but then I want to start by asking, what do I need to know about running a bar? And I started with, well, give me what are the different expenses as well as the possible incomes, okay? And I did that because there is also another concept in prompt engineering that is the tree of thought. And it's pretty much like having a conversation or like helping to the AI to think and taking different possibilities. So like when I told the AI to give me different expenses and like possible income sources, I didn't later take all of them actually. I just wanted to like first of all do the research as I would do myself. I would go to the internet, start getting from different sources information, put it all together, and then decide what is the most relevant information. So I'm actually helping the AI to do the same. Like, let's work first on research, try to understand how to run a bar, what are the main things, and then we will go to the dashboard and analysis. And if that goes well, then I will go and open a bar. But yeah, this is the idea. If you want to later on check it on, you can just write tree of thought, prompt engineering. There are many sources on the internet. This is the first one I found. But it's a useful way of building prompts. And well, this is just the prompt literally I wrote in Claude. That was the first output. Then I thought like, oh, that's too much. And then told to forget about the additional. It wrote a lot of additional things that I didn't want in the first iteration of the bar. I didn't want a kitchen, for instance. I just wanted drinks. So I said, like, forget about the food. Just get with the drinks. That's one thing. And at some point, actually, it gave me a good presentation. I will show you the Streamlit dashboard soon. But it had a lot of straight lines. Like, everything was going up perfectly. And I was like, oh man, that's not reality. And told the AI, like, you gave me a lot of straight lines. Everything is going up nicely, smoothly, but that's not reality. Can you do a better model? And actually I started to take into account the different seasons, like winter, summer, whatever. And also how like popularity grows over time if you do it well. So yeah, and that was the code that generated. The cool thing about Streamlit is that usually you have between 2 or 100 and 300 lines of code, and that's all you need. And you don't write it. Like, I mean, you don't need to write. The cool thing is that you don't even need to understand how Streamlit works. You just ask for it, and it does it for you. So yeah, in case someone wants to check it. I also ask it, like, just at the bottom of it, there is a graph saying where is the kasumilave punkt, the break-even point. So how many months it's going to take until it becomes profitable. So also asking, so what is the initial investment of capital that I need to open a bar, which is around $100,000, whatever, euros, sorry. And after 1-2 years, it's going to be nullified. And then from then on, it's going to start to be like a pure profit. That's ideal, of course, that's not reality. But with this one, you can play with, okay, what's the space I have? How many square meters I have? How much staff do I have? How many like bartenders do I have? How quick are they? Are they serving the drinks? You know, how much people are going to come per hour? What's expected people? In the model you have, it's like an average per hour. I don't remember if it says like 15 or 20 persons per hour. Of course, it's never gonna be like a stable number of people. So one thing that you can do in the next iteration is to ask like, that's not realistic. It's gonna change over the different times in the day. So take that on account. And you can add as a parameter, and then in the dashboard, play with it, change it, and just like play around. What the problem with this is that, of course, it will break eventually, but we don't care. This is for prototyping. We are not building a product here. We are just building something that we need to check before launching another product, or that we want to show to our team, or we want to pitch an idea and know if something is viable. So that's one thing. But there are actually typical errors that happen when you want to use a Streamlit. These are the 3 most common I have had with the different examples. And they are all related to library versions, pretty much. So if you just downgrade the NumPy library to 1.23 whatever, like before 1.24, then it's fine, because that's from last year. Then also Bouquet, you sometimes have to do that. And if you have setup tools installed apart in Python 3.11, then everything works like a charm. So my recommendations is that if you want to do something like that, just start with these 3 things or 4 things. This using Python 11, 3.11, sorry. We are still in the 3, not in the 11. Also having the requirements.txt with those like 5 things, those are usually, without the pip installed there, those are the things that you're usually gonna need. So you can just open a GitHub repo, new GitHub repo with that, and then ask the prompt, put it in your GitHub repo, upload it, and deploy it in a Streamlit, and that would be the workflow. You don't need more than that. Sometimes it happens that it gets stuck fixing a bug or a typo, like it happened with the var example, that there was one variable that was getting it wrong all the time, and I was saying like, hey, I'm getting this error, like literally. I was not correcting the error myself. I was saying like, I'm getting this error, and the error is just that the variable is not defined, and it didn't fix it after like several iterations, so I just fixed it myself very quickly, and then every time I tried to generate a new script, I don't know, with a new model of how the seasons are going to affect, okay, I know that the script that is going to generate to me, I will just have to change this variable that was not able to fix. So, I mean, being a bit of a programmer, that's not a big deal. That's something easy to do. And then if you check the GitHub repos of those dashboards, there is a fancy README file. I didn't spend much time writing it. I just asked the AI to do it. And, well, change some writing, some spelling, or some URLs so that it would actually work, the URLs and the images. But then the rest is just pure AI. So yeah, this would be finally the useful thing of this talk, I would say, is just to follow these steps of setting up the environment using, I would recommend using a virtual environment in Python, then just the 3.11, then open a GitHub repo with a proper setup git ignore and the requirements.txt file. Then just write the prompt, iterate a couple of times if needed, update the result in GitHub, put it on the Streamlit, and share it to the team if that's needed. Then it comes the hard question of what are the iterations that you need to fine-tune it, but yeah, that's it. And I think this was the last slide, probably. Yeah, just thinking I'm something of an engineer myself, or pretending to be. So yeah, thank you to you all. If someone wants to later connect, just if you want to connect, just write a message, because I usually don't accept people I don't know. So if you say that you met me in the event, then I will accept it. If not, I will probably ignore it. Just saying, I don't want to give a chance to bots. So if I don't know someone, I just, no. So that's all from my part.
Thank you, Javier. Thank you. Let's try to switch to the next slide and see whether we have questions. We have none of now, which is okay. Does anyone have live questions to Javier? How to be prompt engineering? Or I bet people will remember you as the prompt engineering coach after this event.
Yeah.
Please.
I don't do this that often, but
Hello, what's your take on your students in high school using AI for coding?
that's a good question. Actually, in the first class I have with my students, I show them myself how they can use AI to solve the exercises that I give them with one intention. I tell them like, hey, you see, you can use this to solve the exercises I'm gonna give you. Now, then I ask them like, why do you think you wouldn't want to do that? So then we have some kind of a dialogue, and I usually try to guide them to come to the conclusion that I'm teaching them a programming basics course, so they need to understand the basics. So later on, they can use AI more properly, understand what the AI is given to them, and also like explaining that someone still has to build all the pipeline behind it. Someone has still to build all the AI things. So if you don't, I mean, you can use it later on when they have the exam. They cannot use it, so there is no use on that. When they use it for the exercises, I don't check it. Like I just check that they have done the exercise, and I tell them. I also can see when someone has copied from someone, or I see in the exam that they have used the AI because it's too fancy for them to write it. So it's pretty obvious to see. Last year I had one girl using the AI for the second exercises. I remember pretty well. I saw it. I looked at her in the eyes. I said like, you used AI, right? And she was like, yeah. And I mean, it's so obvious, so you cannot hide that. It's also fun because I have seen some interesting solutions that the AI has given that I didn't think myself, especially with using Arduino and electronics. But yeah, my take is that I encourage them to use it, knowing what they are doing, but also not using it for like basic things, so that they can actually have the critical thinking and understanding to later use it better. So the goal is that I tell them that you want to use it in the future, but you need to be good so that you can use it better. I don't know if that helps or makes sense.
Yes, thank you.
You're welcome.
Yeah, it's like if you don't know, it's fine. But because there was this option to deploy in Snowflake, do you have any idea what that looks like, or what that means?
No, I'm sorry, I'm lacking experience on that part.
Yeah. Okay.
Yeah, I'm not gonna make it up. I just don't know. I'm sorry.
So you developed an app to analyze, is it profitable to open a bar in Estonia? So are you going to open a bar in Estonia?
Hopefully one day. Actually, I've been seriously thinking about it. Probably not this year. I have too much on the schedule already. But yeah, you might see me in a bar sometime in the future. Yeah. As a customer, you can see me today. Well, today probably not, but tomorrow definitely. But yeah, more as an owner. But I put the example of the bar because that's actually similar to what I did for the protocol in our company. And it's that you can actually analyze what are the different parameters that are related between each other, and you can play with it. In the example of the bar, they actually didn't change much, but I guess my idea was to try to transmit that you can model systems very quickly that are also like interactive, that you can play with it. But yeah, going back to the bar, yeah.
Yeah,
what will be the name of your bar? I don't know yet. If you have suggestions, I'm open to it. You can list them here. Probably we'll ask AI to give like 100 of them and then start iterating. I did. I usually organize also in summer camp for young kids. And like 2 years ago, we didn't come up with a good name because every year we have a different name. And we generated like, I don't know, maybe 200 names. And we find like very stupid ones, some cool ones, and decided on one of them. Well, actually, we never, at the end, we didn't use any of the AI ones, but just, yeah. Claude. I use Sonnet 3.5. I find it very useful, especially for the artifacts. I use, as an LLM, I use Claude. I use also ChatGPT, probably will be coming back soon to it because of some new features that I heard of in a podcast this week. So I will play again a bit more with ChatGPT, also with Grok. I haven't played with Grok, so I will check. But yeah, at the moment, Sonnet is pretty much. Do you know any nice tool for finding a name? No, otherwise I would have used it. Probably my little cousins, they are very creative. I will not tell my auntie that I call them tools, but they will probably be happy about that. So,
all right, we can call it a meetup then. Thank you so much, Javier.
You're welcome.
Thank you. And thank you for coming. That's it of the official part. You can still stay. We have some a bit more snacks coming here. Please enjoy. Thank you. Have a nice evening, and have a nice Independence Day in the morning. Monday.